This is his third, fourth time speaking at this conference. Spoke at a lot of them. I think he missed 1 year. I don't know why. We'll get to the bottom of that later, why he missed 1 year. But he hasn't taken a vacation in 3 years. Well, he hasn't taken more than a 1-day vacation in 3 years. And his first vacation in 3 years starts tomorrow. So he's gonna, but he's gonna miss half the conference tomorrow. But good for him, right? Good for him. All right, let's give him applause for that. Yeah. But he promised he'll watch it virtually from the road. So everyone, please welcome Rafi.
Good morning, everybody. My name is Refael Lav. I am a lead data scientist with Deloitte, GPS Federal. We doing a little bit also state and local and commercial, but mostly focusing on advanced analytics in the federal space, crossing over all agencies. And essentially, the story, what I'm going to talk about this morning, you're not going to learn anything new. This is really about how we took essentially something that all of you know, a little bit of clustering, a little bit of modeling, a little bit of a markdown, and really put it together to create a utility. This is actually not something that sits on your laptop, not something that only you know or end up in a PowerPoint for a decision. Nothing wrong with the decision, but how do you actually impact the process? How do you impact an entire agency? How do you impact the lives of 1,600 families using tools that you already know, that you already have in your positions, and doing it with tools that you know already. So let's start by really talking about stop moving. All right, let's start with a little bit of a kind of like setting the stage. So what are we trying to do? Again, I'm not representing the agency over here. This is really talk about R. But in a few words, what USAID is trying to do is to utilize capabilities, utilize data to make informed decision on where there is a demand for their foreign service officers, for their individual around the world, not as necessarily as a response to a crisis. So that's like, Ukraine, for example, not as that, but as a general course of business, where they're distributed all around the world. How do I know what kind of peace officers do I need, health officers, and where? Can I really use a capability with the data and then align them to the right place? Couple of terminologies that I want to make sure that we're aware of here. So a mission is a location. There is also regional, which is essentially an area. So a mission is, let's say, Laos. A backstop is a particular function within the mission, or a particular function of think about this as a job series. You can see this on the right over here: engineering, environment, education, democracy. And finally, the point over here is that we have a lot of different mechanisms: FSO, FS, CS. I'm going to use that, but essentially it's foreign service officers. The other mechanism of hiring for a position, CS is civil service, somebody who's permanent over there, and there's temporary as well. What's interesting about this, and you can see this on the table on the bottom right, is that we are talking over here about numbers that are being controlled by Congress. So it's not like they can go and hire whatever they want. It essentially, there is also a limit. So I can come and calculate that I need 10,000 people. It doesn't matter because Congress only allowed us to do 16, for example, actual 2019 was 1675. And by the way, you can see this number in 1980 over here. This was a direct result of the work that you're about to see in a second, the fact that we went up. So again, our tools are valuable. It's about utility. It's not just about it's cool. So what do? We did this. Now, I don't expect, this is kind of like the process. That's not the point. But the point is that every item over here was controlled by R. So let's start speaking for a couple of minutes around the data. So what do we have over here in order to support our data? We have anywhere from headcount information. And by the way, the numbers that you see over here, the visualization, those are not real numbers. that's not the point, and not real titles. I changed most of them. But that's how the tables looks like. So we have information about people. We have information about grades. We have information if they're supervised or not supervised. We have information historically where they were. So I know who was where, at what position, and theoretically what they touched, and how much of money, and we'll talk about money in a second, they touch, and what kind of information did they know. I know historical, right? So we spent $100 million on democracy in Afghanistan. I also know information around the future, like what do I want to accomplish? Because essentially we want to do, this is all forward looking. What do we want to do next year? So we have information. So think about tables in PDFs, right? Extracting those, not crazy sophisticated. This is not deep learning, but not that deep learning is sophisticated. It's really just regression, but whatever. We essentially have all this information to collect, as well as we have specific information about local. We'll touch on the data call in a second. That's probably one of the coolest, most impactful things that we've done over there. Essentially, how do I collect something that is local? What happened on the ground? So let's talk for a few minutes about model approach and how that's impact the capability. And all of this, again, give me another minute and then we'll get to the R stuff. So we're starting with the different concept. I want you to understand the concept of, we have historical information, right? I want to do a prediction. I need historical information. I know how much, when, where, who, right? I have also the level of effort by implementing partner. So that's the data call. It's all local. $1 in Afghanistan is not the same as $1 in Greenland. It's also, if I write a check, it's a lot easier than I have to manage that, dollar by dollar. So how do I make sure that I account for the fact that it matters, the level of effort matters? How do I translate that all to something I can predict? So that's really the key over here, measurement of work. It's unitless, new unit that we developed for USAID. It's unitless unit. It's essentially measure that, you need 400 measurement of work for a particular location. And then any sort of adjustment that we might need. It looks like this, and this is where we're going to start getting into how do you drive utility from your art capability. We're really starting from the base model, which we have the MOW. This is where I can kind of take all the information and kind of predict that. We get to the next level, which is I kind of starting to think about everything is local. What's the information that I know about the local? How many PhD in economics I have in a particular country that I can use to help me in economics versus I have no one and I need to bring them from the United States, or I need to outsource that to somebody who doesn't know much. I'm following up. So MOW, that's model. We'll get to the XGBoost in a second and others. The base with adjustments, that's the data call. Markdown, that is a survey. That is the analysis of network. The global strategy, for example, development priority, climate, DEIA, as well as some sort of limitation. There's certain rules that we have to adjust for. And then any sort of mission level calculation. And by mission level calculation is like, our president shows up in a particular mission, there's preparation, there's work that needs to be done. That does not account in anything. That's just like, on top of everything. But from a measurement of work, we need to account for that. So that is where we start taking all the information in the process that you saw a second ago that you don't have to remember. That's where you actually make those adjustments. And finally, okay, let's say that we predicted that you need 5,000 people. How do I go back and say, I only have 1650, I only have 1850, right? As we saw in the first slide. How do I go about that? That's when we design, and this is essentially, it's kind of long, but again, within your capability, this is where you have an if-else statement, a looping, and essentially we are accounting for the marginal benefit of the next position. And you start from the top and you start going all the way down with adjustment, so we can decide that a particular mission, a particular area will be fully funded, for example, fully staffed. So you can adjust for that. But again, this is not super rocket science, but you can actually take and design a waterfall in your regular R, wrap it up, and we'll talk in a second about how we wrapped it, and kind of making a decision, hey, our model says that you need 10 people, but according to the waterfall, only 5 will be available, considering the fact that we have limitation from Congress. All right, so what does R has to do with that? We'll start from the model. So essentially what you see over here is that that's the left side, right? We talk about MOW and the design. This is where we start talking about actual model. So we have a model that was trained on historical data, and we kind of generated the last year and compared to what we actually have. Each mission was, and each backstop was modeled. And what's really interesting over here is, as you can see in the visual, this is where we got a lot of utility. This is where we actually had the buy-in. On the right side, you see the 45-degree angle, actual versus predicted. For those, this is ggplot, and this is the Wall Street Journal type of visualization. So the colors and everything. But this is ggplot. And this is where we had like the head of HR, the head of the agency is looking at that. They're like, okay, I get it. This is where I have like actual is a little bit higher, but this is where, and we'll show in a second how we actually show the output in the same kind of matter. So visualization matter. We really had 2 models and this is, again, nothing over here. Everybody who's sitting over here probably can do this. This is not about something that only we know. It's really about putting the pieces together. So we have a mixed model over here that really does most of the heavy lifting, what we call the base. And then we have the XGBoost that really look at variables, that really looks at the importance of the different variables and the different mechanism and really what we need to account for. And the way that it looks like is that we really have an aggregation of the both. It's really combined. And this is where, again, you need to think about, it's not just about I have a model, I deploy it, I'm done. It is about how do you take the different components and really put them together in a way that actually makes a difference, in a way that actually produce something that people can use. It's actually valuable. And in this particular case, you can see that this is a particular backstop, and the different variable importance and the mixed model that produce kind of how many do I need in this particular backstop. I removed the name of the backstop over here, but again, the numbers are not real, so that's okay. And what comes out of that one is I need 2 backstop officers in Ethiopia for this particular work for next year. So, and that's how we visualize that. And you can see that, again, we have on the left side over here, we have the model prediction for a particular backstop, which one is over, which one is under. And again, this is very easy to explain. 45-degree angle, everybody understands. This is not, AUC and precision and that kind of thing. On the right side, you can see we can do the same thing on the mission level. We also accounting for the clustering of the different funding mechanisms. So we want to make sure that you stay within your cluster. There's a reason why a particular bureau or a particular mission is doing the way that they do. There's obviously a long history of to why. So taking that into account. None of this is specifically interested by itself. Although the clustering is actually very interesting because that's something that the response that we got is that, hey, this is exactly what I thought about, but I never actually was able to put it together. And this is where it actually came in very nicely. The final couple more points. One, this is when we started to look at the positions. So how do we communicate that? One communication is you can see that the fact that there are positions out there in a particular bureau it's rolling. The mission is changing over time. And you can see, for example, the different types of backstop that are in color coded. You can see that some of them went all, and it's from, again, left to right. Positions rolling over from this type of work to this type of work. And when you explain that in that kind of way, that we're taking into account the fact that old positions are no longer part of the picture, but the new positions are. Even though it's the same backstop and it's the same location, the same mission, really we need to take that into account, that it's only the ones at the end that really matter. The ones that are open from like 20 years ago, 30 years ago, that's not what the mission is doing today. So visualization matter. And finally, we spoke about court over here before. This is still in Markdown. We can fight about this later. But in Markdown over here, what's really nice about this is that we did the global data call. All missions around the world respond to this. And then you can really take the right information that you need out of this one. You can do the cross tabulation. You actually have a report that our clients can submit to their leadership. We actually have an understanding, as you can see on the right, of what is important and what is not, and in what level by the mission. And then incorporate that into the model, as we discussed a few slides ago in the process. So Markdown was actually a really key over here in selling this. And essentially, that's something that you can attach to an email and send it across without individuals having to learn how to operate the dashboard or download anything. So as a communication tool, that was key over here. One thing that I want to mention over here, for the sake of time, is how do we actually deploy this? So the interesting part over here is that we actually have a platform. So how do I communicate with R to a platform that really is based on other technology? In this particular case, our solution was R2PY, which is essentially a wrapper. It's a Python wrapper for R that you can essentially run underneath, and Python is kind of running on top because the platform is in Python. So it is essentially not an API-based couple. My last talk over here was about how to you really utilize API properly, and really this is the future. But in this particular case, because everything is on-prem, on-platform, this is one solution. If you learn anything from today, this is probably it. It's actually very powerful, that you can develop all your work in R, develop all your functions in R, all your model in R, and you actually interact with that through Python because the operation is in Python. Final piece over here is, and we can't go without Shiny. So all of that is then wrapped into a really pretty Shiny, so that we can communicate that to the users, to the team that actually need to utilize that. And you can see that you have like the actual numbers. You can have in the middle of the bottom left over here, you can see the blue and the green, the blue and the red. That's optimal versus actual. Remember the waterfall we talked about? I can show you, you need 10, but you're only going to get 5. And then we can also show you kind of the distribution. You can get the data out through the tables. And what's really nice about it is that you can actually change parameters, and you can actually change and interact with that. And this is something that was net new to them, which is the ability to run scenarios. That is really interesting. Now, eventually, this Shiny went into an actual a platform that took the Shiny and copied that into a different platform. But without the Shiny, we will not be able to communicate. I will use my last 30 seconds essentially saying, going back 4 years ago with my first talk, this was from there. And this is really the point, again, the same point. I just realized at the end when I finished this presentation prep, I've realized that I'm really talking about the same thing in a different scenario, which is essentially the model is part of a process. You solve enough little point over here, and you will get some result at the end. It's not about finding the most sophisticated model. It's about finding utility from what you need, and really understand what is the data that you control, what is the data that you need to generate, and where do you go from there in order to create a solution that creates a utility for your client. Thank you very much.